Hi, so for this particular part of this lesson, we will now be working on graphing nonlinear functions, okay? So what is the graph of a function rule? The absolute value of x minus 4. So just like what we have been doing from before, it's always important that we create a table of values so that it's easy for us to identify the specific points using the ordered pairs, and then we can plot them on our graphing area. Okay, so we have our x values first. Okay, so we typically start with the numbers that are very close to 0. We can have that. Okay, and then we will have our y value, which is x absolute value of x minus 4. Okay, so this is your y. And then here we will get our ordered pair, which is xy. All right. So let's have the first one. Let's say we have an x is equal to -3, -2, -1, 0, 1, 2. Okay. So like I said, you can start with -2 to +2. You can have that. It depends on typically we start with the ones that are in the middle. Okay, so we will have the absolute value of -3 minus 4. So that's gonna be 3 minus 4, which is -1. And so we will have a -3, -1 point. So -3, -1 points, it's gonna be here. Oops, sorry, my bad. Oops, oopsies. Okay, let me get that point. -3, -1 is this point. Okay, now let's have -2 minus 4. So that's gonna be 2 minus 4, which is -2. So we will have a point at -2, -2. So -2, -2 is gonna be here. Oops. -2, -2. We have a 3, -3, 1. It's gonna be here. Okay. If we have a -1, so absolute value of -1 minus 4, so that's gonna be 1 minus 4, which is -3. So we have a point -1, -3. -1, -3 is this point. Absolute value of 0 minus 4 is equal to 0 minus 4, so that's -4. So we have a 0, -4. It's gonna be this point here. So if we have 1, absolute value of 1 minus 4, so that's 1 minus 4. We're going back to -3. So you will have 1, 3 over here. So 1, -3, I should say 1, -3. It's gonna be this point here. If you have +2, absolute value +2 minus 4, it's 2 minus 4, which is -2. So you will have a 2, -2, and it's going to be over here. Now, if you will notice that if you continue the +3 and then +4 and stuff like that, the graph will actually be something that is V-shaped. Okay, so the graph of this will be something like, oops, sorry, I'm trying my best to keep it as straight as possible. Okay, so it's going to be like that. So that's how your absolute value graph would look like. So for this function, this is y is equal to the absolute value of x minus 4. Okay, so it is important to have a table of values so you can identify specific points, you can graph them, and then typically you connect those points. All right, so why don't you try this next example here? And our equation now, sorry, our function rule now is going to be y is equal to x squared plus 1. So go ahead, try out, identify some x values that you would like to input to the function, and then what will be the output, the corresponding outputs for that. Try it out. So once you have put in some values for x, -2 to +2, and you plug it in each of them to the function rule x squared plus 1, so you can see here the value of x got squared plus 1, so that will be a 4 plus 1, which is 5, a 1 plus 1, which is 2, 0 plus 1, a 1 plus 1, a 4 plus 1. And those corresponding points are over here, and the graph will actually be what we call as a parabola. It's like a U-shaped graph, and you will notice as we move on also to our other chapters later on, you will see that if your function has an x squared, your graph will be a U-shaped graph. Okay. So to summarize our lesson for today, the set of all solutions of an equation forms the equation's graph. Okay, so you have your inputs and their corresponding outputs. You plug them into our graphing area. That's how it would look like. A graph may include solutions that do not appear in a table. So real-world graph should only show points that make sense in the given situation. All right, thank you.